Good morning, children. Today we are going to see different form of energy. In our earlier session, we had learned about energy. Now let us learn about different form of energy. In our earlier session, we had already learned that energy is the capability to do work. In our nature, there are different form of energy. Now let us see the first form, and that is the mechanical energy. Mechanical energy is the sum of kinetic energy and potential energy, which means it consists of motion and position of a body. In the other word, we can say that an object which possesses a mechanical energy, which means it has the ability to do work due to its motion and position. For example, if a car possesses a mechanical energy, it is because due to its motion or the kinetic energy, and the object which is being raised high upwards vertically from the ground possesses a mechanical energy, it is because due to its position. Or we can say the object has the stored form of energy, and that is potential energy. Now, we came to know that mechanical energy can either be called as kinetic energy, the energy that is in the form of motion, or the potential energy, the energy that is in the form of position or the stored energy in the object. Now we will see the heat energy. Anything that gives off heat is a source of heat. For example, burning wood or an electric bulb. Now let us understand an experiment. Suppose you keep an aluminium sheet in a sunlight for few hours, and then you touch it and place that same sheet in a room, and then for some hours you touch it again. In the first you feel it hot, and in the second you will feel it cold. This source tell us that sun has the source of heat energy. Now let us understand another experiment. For example, if you place a magnifying glass over a thin sheet of paper, and the sun rays which is coming from the magnifying glass first turns the paper into hot, and then start slowly burning it. Other sources of heat are wood, coal, gas, etc. Steam possesses heat energy and is capable to do work. For example, running of the engine of heavy duty vehicle or the cars, and also the aeroplane. We generally don't touch the object which is heat highly, because it can burn us, and the electricity used in the computer also gives the heat. Now the other form of energy is the light energy. Light is a form of energy which enable us to see things around us. We do not feel light energy because it's an ordinary light does not move the object around us. The property of light is light travels along a straight path. For example, you must have seen the light of the sun, which travel along the straight path when it comes towards the earth. But generally you can't see it because in all over the light cannot be seen that it is traveling along a straight path. So we can generally see it in the dark room through a small hole through which the light is entering in the room, and over there you can see that the light is actually traveling along a straight path. Speed of light is measurable, and the speed of light is 3 into 10 to the power 8 meter per second. Light travels along a straight path. Let's see an experiment. Suppose you can take four cards and make a hole in it, and arrange in such a way that the holes are arranged equally towards one another. Then, if you are taking a laser beam and passing through that hole, you may able to get that the light which is traveling along a holes can easily be seen that it travels along a straight path. Now, our next form of energy is the chemical energy. Chemical energy is the energy which is stored in food we eat. When we eat food, our body breaks down the food chemically to give out energy. This energy stored in matter is called chemical energy. Chemical energy is in the torch. On switching a torch, the chemical energy stored in a cell operates to give light. It also consists in wood or the burning coal or the kerosene. Now, the other form of energy is a sound energy. Sound is a vibration that travels through a medium like air or water. For example, if you drop a rock in the bucket of water, you disturb the surface, which causes the wave to ripple away from each other. Thus, you can see the wave formation that is formed upwards and downwards. The upward formation of wave is called the crest, and the downward formation is called the trough. And the distance between the two crests is called the wavelength, and the displacement of wave from its mean position is called the amplitude. Thus, we can hear the sound when the number of vibration is produced per second, and there is a frequency, and the speed of sound is traveled and can be calculated by wavelength into frequency. When we clap a hand in a quiet room, we actually disturb our air, which causes our air to ripple away from each other and causes the upwards and downward formation of wave. Now, we will see the another form of energy, and that is the magnetic energy. We know that a magnet can attract iron fillings or pins, or hence it is a form of energy which is used in many factories to load the scrap iron and separate a heap of waste material by using a big electromagnet fitted to a crane. Now, the other form of energy is the electrical energy. Electrical energy is basically used to run the heavy machinery in the large industry of manufacturing, or it is also used in the shops. Electrical energy is also used in charging the mobile phones and the laptops, and also runs the television. We receive electrical energy from nearby substation or the pole which is nearby to our houses, which supplies the electricity through the wires. Electrical energy can also be converted into light energy, sound energy, or it can also be converted into a heat energy. Now, our last form of energy is the nuclear energy. Nuclear energy is the energy in the nucleus or core of an atom. Atoms are tiny particles that make up all matter in the universe. Atomic energy can be used for a peaceful as well as for the destructive purposes. Energy hold the dense nucleus. Nuclear energy can be used to create electricity, but it may first release from the atom. Two kinds of atomic reaction takes place. In the nuclear fission, atoms join together, and in a nuclear fission, atoms are split apart. However, nuclear power plants do not have the capability to produce energy from the nuclear fusion safely. So, nuclear reactors are used pellets of the element uranium as fuel. The nuclear reactor forces the atom of uranium to break apart. As they split, the atom releases tiny particles called fission product. Fission product cause other uranium atoms to split and start a chain reaction. The energy released from the chain reaction creates a heavy heat. A nuclear fission warms a cooling agent. The cooling agent produces the steam that turns the turbine and due to which the electricity is produced. I hope you all have understood what are the different forms of energy. Let us now see the two forms of mechanical energy, and that is potential energy and kinetic energy. Potential energy is energy of a body at rest is called potential energy. Let's understand more clearly with the definition of potential energy. The energy stored in an object because of its specific state or position is called potential energy. The SI unit of potential energy is joule, and the formula for potential energy is mgh, where m stands for mass, g stands for gravity, and h stands for height. Means greater the height of an object, greater is the potential energy. Now let's understand it with a simple experiment. In this experiment, there you can see a two sphere. The blue sphere has more gravitational potential energy because it is at a great height, and the yellow sphere has less potential energy due to its height. When the blue sphere skates down, it comes with a greater speed, and the yellow sphere comes with a less speed as compared to the blue sphere. Thus, the potential energy explains that the greater the height is, greater will be its energy which is in the body. Let's understand it with one more experiment. As you can see, there are two balls which is having a mass of 1 kg, but one ball is having a height of 1 meter from the ground and the other ball is having a height of 3 meter from the ground. So which ball will have a more potential energy? When we will keep it in the formula mgh, so mass of the ball is 1 kg, g that is 9.8, and h that is 3 meter of the second ball. So from that we will get that the second ball has the greater potential energy. Now over here you can see that there is a blue ball and a red ball and a green ball. So which will have a greater potential energy? Of course, the red ball due to height. Now the kinetic energy. The kinetic energy, the energy which an object has because of its motion, and the kinetic energy has the formula half mv square. Now let's see in the formula that k is equals to half mv square. Here m stands for mass and v stands for velocity. For example, we have taken two cars which are moving with a different velocity on a road. First is moving with 10 meter per second and the second one is moving with 30 meter per second. So which car will have more kinetic energy? Of course, the second one. Why? Because when we keep it in the formula, the velocity of car 2 is greater than car 1, so it's have the more kinetic energy. Now the ball that is being kicked by a footballer possesses a kinetic energy in it. Now let us see factors affecting the kinetic energy of a moving body. The kinetic energy of a moving body depends on the following two factors. The first is the mass of the body. Greater the mass of the body, higher its kinetic energy. And the second factor is the speed of the body. Means more the speed of the body, more its kinetic energy. Now let us understand the conversion of potential energy into a kinetic energy with a simple example. Suppose a box at a height has the potential energy due to its lifted or raised position. When the box is coming down from that position, it begins to slide. The sliding box has a kinetic energy. Thus, the potential energy stored in the box in its raised position changes into kinetic energy when the box is started to slide downwards. Thus, the kinetic energy works with the gravity of our Earth. With this simple example, I hope you have understood how the conversion of potential energy is done into a kinetic energy.